In this video, we are going to see about principles of PET. What is PET? Positron emission tomography. It is an advanced CT machine. Okay. As I already told you, positron emission tomography, PET. Positron emission tomography is an imaging technique which uses small amount of radio-labeled biologically active component to help in the diagnosis of disease. Okay. Positron emission tomography is an imaging technique which uses small amount of radio-labeled biologically active components. Okay, radio-labeled and biologically active components to help in the diagnosis of disease. Okay, what we are going to do in the positron emission tomography is that we'll be producing passing a trace into a body, which in terms of an injection or inhalation of a tablet, or in terms of a gel. Okay, we'll be using these three things. We can opt any one of the thing to trace into the body. By using those materials, we can see the images in the screen. Okay, the traces are introduced into the body by either injection or inhalation of a gas. As I told you already, in terms of injection or a tablet or an gas, inhaling a gas, we can by inhaling those things, it will go and reach the place which has been affected. Okay, by using that and by using the with the help of doctor, we are going to identify what has happened in the body by using the positron tomography, positron emission tomography machine. Okay, PET scanner is used to produce an image showing the distribution of traces in the body. This will identify clearly what has happened in the body. Okay, it will be distributing the traces all over the body. The traces, in the sense, the thing which we are inhaling is called traces. That will go fall or fill into the tissues which it is founding, and that will be helpful to identify what is happening. Main system components. What are the system components in this? Scanner, grantee, detector, stepper, coincidence circuit, table, computer, cyclotrons. These are the components in the main system main system of the PET. Scanner, grantee, detector, septa, coincidence circuit, table, computer, cyclotrons. Detector. What is a detector? Comprises of 8x8 scintillation inorganic crystals which emits light photons. After the interaction of photons, blocks of scintillation crystals. Okay, comparison of 8x8 scintillation. What is a detector? Detector contains 8x8 scintillations. From the diagram you can see that 8x8 boxes has been given. That is called scintillations. A single block of scintillation crystal, I have mentioned, the diagrams has been mentioned here. This is single detector element. Okay, each one consists of 8x8 scintillation inorganic crystals which emits the light photons after the interaction of photons. Okay, blocks of scintillation crystals. 4 photomultiplier tubes arranged in a circular pattern around the patients. 4 photomultiplier tubes You can see the blocks of scintillation crystals over in this wheel. This one is called one block. This complete pack, you can see this diagram, this complete pack will be placed in the circle detector. Circle arranged in a circular pattern around the patients. The patients will be in the Z axis, as I mentioned here, will be in the Z axis. Okay, next is septa. Lead or tungsten circular shield mounted between the detector rings. Okay, lead or tungsten circular shield mounted between the detectors limit scattered radiations from the objects reaching the detector. Okay, scattered out the transverse plane. Okay, limits scattered radiation. This septa is used for limiting the scattered radiation. By using septa, we can control the scattering of rays in the other places. Next is coincidence circuit. What is coincidence circuit? Specific electronic circuits, that is coincidence circuit, picks up gamma pairs due to two gamma rays emitted during the positron's inhalation almost simultaneously. Okay, specific electronic circuit, that is coincidence circuit, picks up gamma pairs, okay, due to the two gamma rays emitting during the positron. When in the PET, that is positron emission tomography, we are going to use the gamma rays. Okay, by emitting when the inhalation process has been done, the gamma rays are going to emit on the object which has been affected, and by using the gamma camera we are going to detect the objects which is affected. This coincidence is a very strong signature that distinguishes them from other photons. This coincidence circuit, that is coincidence, is very strong signature that distinguishes them from other photons. Okay. On the image, it is requested that the signals coming from the scintillation A and B coincides within 12 billionths of the seconds. 12 billionth of a second, that is nanosecond. It will take a very small 12 nanoseconds, billionth of second, that is nanoseconds. This images will be taken. Next is cyclotron, a machine used to produce the radioisotopes. Cyclotron is a machine which is used to produce the radioisotopes, radioactive chemical elements, right, which are used to synthesize the radiopharmaceuticals. Radiopharmaceuticals is the element which you are going to inhale, or the way we inject into our body. These are called the radiopharmaceuticals. By using those things, the radioisotopes will be produced in our body. By using radioisotopes, the gamma rays will also be produced, and the gamma rays will fall on a image which is fall on the part which is affected, and we can imagine, or we can identify those things by using the gamma camera which is present in the PET. Okay. The most frequently used radioisotopes in PET are carbon 11, nitrogen 13, oxygen 15, fluorine 18. Okay. 18 FDG is most widely used PET tracer. 18 FDG, that is fluorodeoxyglucose. Fluorodeoxyglucose is most widely used PET tracers. Table. The bed is capable of moving in and out of the scanner to measure the distribution of the PET radiopharmaceuticals throughout the body. A table which is called a bed, where the patients lie on it, and it will be moving front and back of the scanner to distribute the pharmaceuticals throughout the body. Okay, and it adjusts a very low position for easy patient's access. It will be adjusted in a very low position for easy access of the patients. A computer analyzes the gamma rays and uses the information to create an image map of an organ or a tissue being studied. Okay, the computer is used to examine what is inside the body, what is happening inside the body in the form of an image. Okay. Next, principle of PET, positron emission. How does it happens? Okay, positron emission occurs when the isotopes decay and a photon decay to a neutrons. Where isotopes, we have isotopes and photons in our body. Okay, if those isotopes and positrons decays to a neutrons, okay, a positron and a neutron is formed. After traveling a shorter distance up to 3 to 5 millimeters, the positron emitted encountered an electron from the surrounding environment. The positron emitted will encounter an electron, will find an electron which is surrounding around the environment. The two particles combine and annihilated each other, resulting in the emission of two gamma rays in opposite direction. Okay, these two particles, that is isotopes and the protons, okay, positrons and neutrons, will find an electron in the surroundings, and after those two combination they will emit a gamma rays. After the combination of both, they will emit a gamma rays which will be identified by the gamma camera. Okay. Next, this is the positron emission method. What I told you, what is happening in the positron emission process. Okay. Image acquisition. How the images has been acquired. Synthesis, radio tracer, inject radio tracer, measures gamma emission from isotopes, reconstructed image from radio trace distribution. First, synthesis radio tracer. What radio trace we are going to inhale or identify. Okay, that is has to be identified. Inject radio trace. After identifying it, we are going to inject it into the body. Then measure gamma rays. Once it has been injected, the gamma rays will be produced in the body, and the affected part will be identified. And identifying it after the reconstruction of image. After identifying it, it will be reconstructed by using image processing techniques, and a three-dimensional image will be identified. This is the process of PET, positron emission tomography. Thank you.